Hello, welcome back to the Agile Samurai Bootcamp. I'm your host, Jonathan Rasmussen. Unit testing, knowing it works. For all the time spent planning and managing expectations, Agile processes don't really work unless they're backed by a solid set of software engineering practices. And although some practices like XP's pair programming have been controversial, others, such as automated unit testing, have become widely accepted. In the final 4 sections of this course, I'm going to show you what I call the no-brainers of Agile software engineering: unit testing, refactoring, test-driven development, and continuous integration. Each of these sections could easily be a book in themselves, but by introducing the concepts to you here, you'll at least have a good understanding of what they are and know enough about the mechanics to get you and your team going. The following examples are all in Microsoft.NET C#, though the concepts can be applied to all languages in general. And don't worry if you're the non-technical type. This is good stuff for you to be aware of, and I'll highlight the important stuff as we go. But let's start with the one practice that underpins most of what we do when it comes to Agile software engineering: rigorous and extensive unit testing. Welcome to Vegas! You lucky dog, you just joined a team of software developers building a new blackjack simulator. And your first task is to design a deck of cards. Here's your first cut of the code in C# for a full deck of cards. Now, after writing this class, you make it through peer review, everything looks good, and just before you're set to roll into production, QA finds a bug. There's no joker card in a blackjack deck. You fix the bug, give QA a new build, and release it into production. Then a couple of weeks later, you get a nasty email from the QA manager informing you that there was a major bug in production last night. Tens and thousands of dollars needed to be reimbursed because someone put a joker in the card class. What, you say? Impossible. I fixed that bug a couple weeks ago. Digging deeper, you discover that a summer student you were mentoring took you a little too literally when you asked her to make sure your deck of cards class behaved just like a physical deck of cards that you gave her to test against. It seems she inadvertently added the joker back into the deck. Ashamed and embarrassed, the summer student apologizes to you and the rest of the team. Behind closed doors, she asks you what she could have done to make sure nothing like this ever happens again. What do you tell her? What could she or you have done to make sure that that joker bug had zero chance of ever re-entering the code base once it had been fixed? In this light, let's now take a look at the humble unit test. Unit tests are small, method-level tests developers write every time they make a change to the software to prove the changes they made work as expected. For example, say we wanted to verify our deck of cards had 52 cards in it, not 53, including that joker. We could write a unit test that would look something like this. We've got our class deck test, and there's a method called verify deck contains 52 cards. And in there, we create a new deck, and then we assert that there are 52 cards in the deck. Now, just to be clear, the previous code isn't actually code we run as part of our blackjack simulator in production. This is test code that verifies our real code works as expected. Whenever we have a doubt about how our code is going to behave, or we want to verify it's doing what we expect, we write a unit test. In this case, one that verifies our deck has 52 cards. Unit tests are invaluable because once we automate and make them easy to run, we can run them every time we make a change to our software and know instantly whether we broke something. Typically, Agile projects will have hundreds, if not thousands, of unit tests. They will slice right through the entire application, testing everything from our application's business logic to whether we can store our customers' information in the database. The benefits of writing lots of these against our code base are many. One, they give us instant feedback. When you make changes to your code and a unit test breaks, you know about that instantly, not 3 weeks later after we've rolled into production. Two, they dramatically lower the cost of regression testing. Instead of having to manually retest everything every time we pump out a new release, we save ourselves tons of time by automating the easy stuff so we have more time to test the complicated stuff. Three, they greatly reduce debugging time. When a unit test fails, you know exactly where the problem is. No more firing up the debugger, stepping through thousands of lines of code, searching for the offending piece. Unit tests cut through the fog like a laser and show you exactly where the problem is. And 4, they let you deploy with confidence. It just feels good rolling into production knowing you have a suite of automated tests backing you up. They're not foolproof, but they free you up to test the other more interesting, complicated parts of the system. Think of unit tests as the armor you don before riding into battle. They become a form of executable spec that lives forever in your code, protecting you from missiles, real and imaginary dragons, and most importantly, ourselves. Warning: you will also periodically run into cases where writing an automated test is tough. For example, writing a test to verify you could shuffle a deck of cards is hard, as the answer is random and it would change every time. Also, testing concurrency in multi-threaded applications can be challenging, to say the least. When you run into cases like these, don't despair. They are the exception rather than the norm. In the overwhelming number of cases, you're going to be able to instantiate an object and make assertions on the methods you call. This is even more possible with all the unit testing mocking frameworks we have available today. In those rare cases where you can't test something readily, it may be an issue with your design. Or maybe you've inherited some legacy code that's just really hard to test. If this is the case, so be it. Accept that you won't be able to test everything, but make sure you cover it with some really good manual and exploratory testing and move on. Just don't give up. Always try to automate that chunk of code, because having that little extra bit of armor can really save your bacon when that emergency bug fix request comes in and you have to get a release out fast. Also, you can read Michael Feather's excellent book, Working Effectively with Legacy Code. It has a lot of invaluable suggestions for how to take tough to work with legacy code and make it more open to change. All right, well, that's a simple introduction to unit testing. We've only scratched the surface here, and a lot more can be said on the subject. Fortunately, unit testing is becoming so commonplace on software projects that most modern languages have unit testing frameworks freely available or built right in, with many tutorials showing you how to get started. A good place to start for any developer looking to understand the spirit behind unit testing is Kent Beck's classic introductory paper, Test-Infected Software. Okay, good job. You now know one of the core underpinnings upon which all of our other Agile software engineering practices rest. Without sound automated unit tests, all the stuff falls apart. Next, we're going to look at how to build on our unit tests and do something so critical that were we to somehow skip this practice, our product would become just another overpriced, unmaintainable blob of code resistant to all forms of change. Let's now look at the important practice of refactoring. See you there.